All right, so we are in your student companion on page 53. This launch is what you should be looking at, but we're going to skip that. And what I want you to do right now is pause me here and take a minute and write down all of these properties here. So you're going to write multiplication properties and then write all of these down. And we're going to take notes over here on this side about each of these properties. So you're kind of like setting up a T chart like that. So pause me here now, write down all of this, and play me when you're ready to talk about them. So hopefully you have all these down, and now I'm going to talk about examples of each of them. So multiplying powers with the same base, and we've seen this. An example of this, so we'll put examples over here. Examples of this are something like x squared times x to the third. And remember, when we multiply, we just add the exponents, and it says it right here. We just add those exponents. So now our answer would be x to the fifth. How we got x to the fifth, actually let me show you that, is x to the second plus 3 gives us x to the fifth. So that's our final answer. Now we have power of a power. So that's when we multiply our exponents. And we've also seen this, and it's kind of where I like to, if you're trying to spot them out of a crowd, you see parentheses, and then you see the exponent outside of these parentheses. Now, when you see this, this means x to the second times 3, which gives you x to the sixth. Now, a lot of times you'll see these, and they'll look like 2x to the third. 2x to the third. And in that case, we want to make sure every single, what they call in this book, factor in here gets the third power to it. So what that means is we take 2 to the third power and we take x to the third power. And in my class, I like to kind of call it distributing the exponent. So what that then gives us is 2 to the third, which gives us 8. And then, of course, x to the third just stays x to the third. So now power of a product. It says to find a power of a product, raise each factor to the power and simplify. So that's kind of what we did here, but what they're mainly going to be pointing out to you in this book is when you have things like 2 times 5, and then you want to square that whole thing. Now, you might think, oh, I'm just going to multiply and then square it. 10 squared, that'd be 100. But what they want you to do is, like we did up top, distribute this to each of them. So this now becomes 2 squared times 5 squared, which then gives you 4 times 25, which then gives you 100. And you might be thinking, oh, I could have just times 2 and 5, 10 squared that, and it'd give you the 100, but they just want you to know that that's what's happening. You're giving this power to each factor on the inside. All right, so everyone turn to this page, and it says simplify the expression. So what I want you to be asking yourself with these is, am I going to be adding exponents or multiplying exponents? And in this case, we are adding them, because one trick is there's no, nothing that looks like this. There's no exponents on top of exponents. So not only do we add our exponents, but we multiply our coefficients. So this becomes 3 times 5 times y to the what power? Y to the 4 plus 7. And that's, of course, the longhand way to do it. If you can see automatically that that's 15y to the 11th, then that's okay. That's great. Now, at any point in this, when in doubt, you can just write it out. You can literally write 3 times y times y times y times y times 5 times 7 y's. And I'm not going to write them all out because I think, oh, maybe I won't run out of room. I think that's 7. So you could literally write it out and you'd get 15y to the 11th because there's 11 y's. I'm not going to do that every time. All right, so right next to this, I want you to go ahead and pause me here and try this one. Check back to see if you get the answer. Pause here. Okay, so for this one, you should have gotten your final answer as 48x to the 15th. If you're unsure how I got that, I times 4 and 12. And then I added my exponents for the x, so x to the 6 plus 9, which gives me 15. All right, now let's move on to the next got it. It says, does 8 to the 8th power times 8 squared have the same value as 8 to the 5th times 8 to the 5th? Justify your answer. Well, how we're going to justify this is we're just going to show our work. So we know 8 to the 8th times 8 to the 2nd gives us x, or x to the 8th, x to the 2nd gives us x to the 10th, because we add our exponents. And again, we could write 10 x's out and know that our answer is going to be x to the 10th. Over here, again, we could write 5 x's out times 5 x's out, and again, we get x to the 10th. So yes, these do have the same values because their exponents are exactly the same. All right, that was pretty straightforward. Next, got it. And you try, if you want to take the time now to write that you try over here. I like to split these boxes in half because they give you way too much room. So simplify the expression. And this is what we were talking about at the very top up here. Power of a power right here. You notice, oh, this time we're going to multiply our exponents, not add them. So multiply when you see the exponents stacked on top of each other. And how we want you to write these are g to the 9 times 6th power. And these can kind of go up top. Well, then you just have to figure out what 9 times 6 is, and we know that's 54. So our final answer would be g to the 54th power. So go ahead and pause here. Show your work. Remember, try number 2. Okay, and again, we should have gotten f to the 24th power. How did you get that? F to the 8 times 3, because we are multiplying 8 and 3. That is our final answer. All right, our next got it says simplify the expression. Well, in this case, we are multiplying exponents. Notice how the exponent is on the outside of the parentheses, and we see them stacked up right next to each other. And in the you try, we'll be doing the same thing. So over here, again, like I said, each factor on the inside of these parentheses gets this power of 4. So it's kind of like distributing that power of 4. And I'm going to rewrite it how we want you to rewrite it. It goes 2 to the power of 4 times s to the 5th times 4, because we are multiplying our exponents, times t to the 9 times 4. So you should all be doing that middle step. That's just to remind you that you need to multiply each of these by 4. So now let's get our final answer. What is 2 to the 4th? Well, we know 2 to the 3rd is 8. If we times that by 2, we get 16. S to the 5 times 4, which we all should know is 20, times t. Remember, I'm just stacking these next to each other because it implies that there's a little dot in the middle. Oh, there it is. Times t to the 9 times 4. 9 times 4, we should know, is 36. So this is our answer. 16s to the 20th, t to the 36th. Pause here, and you try this one. See if you get the answer right. All right, so make sure you all did show this blue step right here. 7 to the 3rd, which I got from doing some little math over here, that is 147. Q to the 21st from 7 times 3. R to the 9th from R to the 3 times 3. So this right here should be your final answer. Now we focus on our focus question. How can you apply what you know about multiplying numerical expressions to multiplying algebraic expressions containing exponents? Basically, what they want you to learn from this is in both cases, we are simplifying expressions. Simplifying expressions. And that's true because up here we're taking this long expression and making it a little bit shorter by getting rid of that exponent. Again, here we're taking this longer expression, making it a little bit smaller by getting rid of that 4 right here. So in both cases, we're just simplifying expressions. So now go ahead and start your 3.3 homework. it is 1 through 15, because these are pretty straightforward. Remember to notice when you need to multiply and when you need to add your exponents. There is a difference.